Okay, so this is, I'm just finishing up the previous, what lecture is it? It's lecture 73. We're finding the electron pair arrangement around the central atom, the molecular geometry, the bond angles, and the polarity. So for this guy, we do this out. The Lewis structure is this. We see we have 6 electrons around the central atom, so the electron pair arrangement is octahedral, but the shape, or the molecular geometry, is we have a xenon, lone pair, fluorine, 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 and fluorine, so they're in a plane. The lone pairs are always going to be across from each other if there's 2, because if you put a lone pair here, they'd be right next to each other. Here they're 180 degrees from each other. So this is going to always be square planar. When you have an octahedral electron pair arrangement, sorry, I'm making it look like there's a whole bunch of electrons in here, and there's 4 atoms, they're going to be square planar. The bond angle is going to be 90 degrees. So 90 degrees for the bond angle. And then polarity, there's the fluorines cancel each other, so this is nonpolar. Alright, now we have BF4 plus. I want to just write this out. When you're drawing the Lewis structure, we have 32 electrons for fluorine. Boron is in group 3, so that's 35. Then we have to take 1 away because of the charge. So this is, let's see. Sorry, this is 28 for the fluorine, 3, so this comes up to be, oh, wait a minute. So we have 7 times 4 is 28. Then boron is in group 3, so it should be, so we have 3 electrons here. So, and then this should actually be minus. Sorry about that. So that'd be 32. But if we made it plus, then it would be, just wouldn't work out for us. So this boron, BF4 minus. So as I was doing it, it wasn't adding up in my mind. It has to be 32. So this is what we have. The big point here is not for me to mess up on the Lewis structure, but to notice that we have an ion here. But ions still have a structure, but there's one thing later on we have to deal with. But since there's 4 bonds to bromine, whether it's an ion or not, it's going to have a tetrahedral structure. We put square brackets around it, always do that so we don't lose the track of that minus sign. So that you'll need to do that. You'll need to use these square brackets. The electron pair arrangement is tetrahedral. The molecular geometry, since there are no lone pairs, is also tetrahedral. And you should write out, I'm just trying to save some time here, but you should always write out the full term. I'm doing it because I'm doing several of these. On the exam you'll do 1 or 2, so make sure you write everything out. The bond angle is going to be exactly 109.5, but the polarity, you just have to say it's ionic. You can't say it's polar because we have a full charge here. So that negates any kind of polarity there might have been. On its own, if there was no charge here, it'd be nonpolar, but now it's ionic. So specify that. Don't say it's polar. It's not. A polarity just means a shifting of charge, an uneven distribution of charge, but the whole thing is neutral. So this is an ionic compound, so same thing here. So Cl, let's see if I made the... This one, I think I just took the name out of the back of the book, or the back of the chapter, so hopefully this works out. So 5 halogens, so that's 5 times 7, 35, plus 1 for the charge, so that's 32. So we have 36, let me just double check that, 5, 35, so that's 32, 33, 34, 35, 36. So this is the same kind of, and this is a polyatomic ion, so we have to put square brackets around it. We end up with chlorine at the center, fluorine on the outsides. And then this is in square brackets. So the electron arrangement, there's 6 electron pairs, so this would be octahedral. The molecular geometry, again, I'm abbreviating. You should write everything out on the exam, but you don't want me to write everything out for all 20 of these. Molecular geometry is going to be square planar. The bond angle is going to be 90 degrees. Even though there's lone pairs, I didn't state this before in the last one we did like this, but this lone pair would be pushing down, making this bond angle less than 90, but this is doing the same thing on the other side, so they cancel each other. So they're exactly 90. One of the few times that we have lone pairs where the bond angle is the same as it would be if there were no lone pairs. And then this is ionic again. Now this one, this is the nitrate ion. Now remember that it has a resonance structure, but in this case we only have to deal with one because all of them will be the same. We have 3 groups of electrons. This one has 4 electrons, but it's still one group. So we'd call this one, the electron arrangement would be trigonal planar. So don't think we've been talking about lone pairs or electron pairs, and that's what the theory is, valence shell electron pair repulsion, but it's really electron group. So if we're dealing with a double bond, treat it as if it were as if it were a pair of electrons, but these are all just groups of electrons. So the shape or molecular geometry will be trigonal planar, and then the bond angle will be 120. Now, if this double bond were stuck in this position, say this was, there's sometimes when we have a double bond, and that will take up more room and push down on the bond. But since this is a resonance structure, each of these has that double bond around it a third of the time. So the average bond angle is 120, and then this would be ionic again. So this is several different molecules. I can't draw all of them that are out there. There's really probably 30 or 40 ones that are different from each other. I think there's 16 basic types, but there in each of those types are some variations. So that's about all of the different ones that we should come across. And I'll do some in the lecture, and then any that I've missed would be in the book.